Right, continuing on with the 2020 Oxford PAT, we're on to question 17. So as indicated in the figure, a motorbike with total mass m, which is the mass of the bike plus the rider, is ridden along a horizontal trajectory radius r on the inside of a cylindrical cage. Right, wonderful. The bike and the rider are inclined at an angle alpha at the wall. The angles that the bike can make with respect to the walls of the cage are limited by the handlebars. So a certain minimum, alpha minimum, is greater than 0. Okay, great. The tyres of the bike have a very high coefficient of friction with the cage, so that tyres can only roll but not slip along the cage. Show in a diagram the forces acting on the bike if it's to maintain a horizontal trajectory as shown in the figure. Right, so, well, we've got mass going straight down, well, weight going straight down, I should say, so mg, and then we've got normal reaction force, assuming that is where the bike is touching the wall. Oh, I don't want to call that R because we've got R here for the radius, so let's call that, I don't know, let's call it N. And we'll have friction going up the wall to counteract, call that F, to counteract the weight going down. That's going to be all the forces we've got. At what minimum speed V min must the bike travel if it's not to fall down? Right, well, let's do some resolving then. We've got some circular motion. So let's resolve vertically and say that F is equal to mg. We can resolve horizontally and say that N is equal to mv squared over r. Okay, so we've got those. What else can we say about all of this? Because we're going to want to have, well, we haven't brought alpha into it yet. We're going to want to express V min in things that don't include F and N, ideally. So what are we going to have? Alpha, oh, we can do a tan alpha, can't we? Tan alpha is going to be, so it's opposite over adjacent, that's N over F. So that means now we can put our N into the second equation and, well, and our F as well. We can replace both of those. So N over F tan alpha. So, well, let's do F tan alpha is mg tan alpha. N is mv squared over r. And cancel the m's. And we're going to have the, just wondering why this is going to be a v min. What's the v min? We just seem to have a v here rather than, I suppose we're going to have a, for a particular alpha, it's going to give us, yeah, why is that going to be a v min if it's not going to fall down? So anyway, we got r g tan alpha, square root of that is equal to our v. So v min, oh, v min is going to fit in with this alpha then, isn't it? Yeah, it's going to have a certain angle that we're going to go at in order to get a, yeah, the minimum of this is going to be at our minimum angle. So that's just what our v is. So v min is going to be for our minimum alpha, because tan's just dropping off, you know, r and g are fixed, so that's going to be the square root of r g tan alpha min. Right, so that's all good. Now what have we got? What? Oh, I've just done that bit. Given, oh, they're just giving us some numbers to put in. Oh, okay, fair enough. So work out what v min is. So v min is going to be the square root of 4 times 10 times 1 over root 3, so 40 over root 3. Off to the calculator, which gives 4.8 meters per second. All right, no, that was quite a straightforward question. I don't mind ones like that. Now, what have we got? Question 18. For which x is the following inequality satisfied? Right, let's do some. Yeah, this is a bit different actually. Normally you'd just start multiplying things through, but you can't because you've got that 0 there and we've got a quadratic. So let's factorize. This is ripe for factorizing. So what have we got? We've got a 2x, it will be what, -1 and a +2 on the other side. And then if we want to change the sign of the middle one, we just got to flip the signs around on those. So we need that. So we either need both to be positive or both to be negative. Right, let's sketch these things out then, because there's too many permutations to think about here. So this is going to have -2.5, so we're going to have that and that. That's -2, that is a half, and the other one is going to have the opposite, so it's going to have -0.5 and 2, which means we need, so if they're both going to be positive, then we're looking at this bit or this bit. If they're both going to be negative, we're looking at that bit. So we need x less than -2, x greater than 2, or x between -0.5 and 0.5. That's our, so or. Right, that was straightforward enough. Oh, actually, before I move on, would we be allowed any of the, oh no, it has to be strictly greater than 0. So yeah, I was just wondering if we're going to have any equals to as well. 19, the Euler number EU has no units. It's used in fluid flow calculations, depends on pressure, density and velocity. Is that where those are constants? Right, okay. One of the unit analysis questions. So we've got, so pressure, we've got, let's do it step by step. So that's newtons per meter squared, that's all to the power A. Then we've got density, which is kilograms per meter cubed to the power of B. And then we got velocity, meters per second to the power of C. Right, so let's get rid of this newtons then. Kilogram, so, well, we're going to have meters and then meters -2. So that'll become a meters -1, second -2, A. Kilograms, meters -3, B. Meters, seconds -1, C. Okie dokie. Right, so which one's going to be easiest to start with? Oh, there aren't many kilograms around, so all these have got to add up to 0. So we're saying that A plus B is equal to 0. That's for kilograms. Then, well, there aren't many seconds around, so we got -2A minus C is equal to 0. And then, well, we're probably not going to need the meters one, but let's put it in. We've got -A minus 3B minus C is equal to 0. So we've got A is equal to minus B. We've got that 2A is equal to minus C. So C is equal to 2B. So we need, we just need the ratio of these things. So if A was 1, say, then B is going to be -1 and C is going to be -2. There we go, happy days. Unit analysis ones are always straightforward. All right, question 20. Find the coordinates of the point or points at which the line y equals that is tangent to that quadratic. Right, okay, well, there's certainly going to be points. It's definitely going to be, because we've got a positive quadratic and we've got lines which can be tangent depending on whether m is positive or negative. So we're going to have more than one point. Well, really, we want to have 2 points is what we're looking at. So there's going to be a couple of features of this that we're going to, if we've got this quadratic, we need the gradients to be the same, and we also need to make sure we're not getting these sort of things. We need to have just 2 intersection points, not 4 intersection points. So these are the things that we're looking for when they turn up in our solution. So let's start with a gradient thing then. So we know, well, a gradient, let's look at gradients of this. So y dash is going to be 18x plus 6. And that has got to be equal to the gradient of this, which is 3m. That's an equals. So that means that m is going to be equal to 6x plus 2. So we know we've got that. That is one important equation that we've got. But then we know that they're intersecting. So we can set these things equal to each other. Say that 9x squared plus 6x minus 7 has got to be equal to m times 3x minus 2. So 9x squared, what's that going to be? Plus 6 minus 3m, lots of x minus a 7 plus a 2m is going to be equal to 0. So we want to solve this, but only get two solutions. So x will be, I'm just going to go to the formula for this, minus b, so minus 6 minus 3m plus or minus the square root of b squared, so 6 minus 3m squared, minus 4, so minus 4 times a, so minus 36 times c, 2m minus 7. Wowzers. All over 18. Right, that's quite a lot. So we need this to have just the two solutions. So, well, let's look at what's going on with the discriminant, because if we've got a, yeah, okay, so we've got some quadratic here or in M. So this quadratic in M is going to give us two solutions, right? So those two solutions mean that we're then going to have plus or minus each one of those, which would give us 4 solutions. So we can't have that. We can't unless they're the same. So this bit is going to have to, our discriminant is going to have to be equal to 0, because then we're going to have two values of m which give us 0 in there. And then that means that then we're just going to get two answers. Yes, that makes sense. Right, so we need 6 minus 3m. You'll see, if you don't understand what I mean so far as to why that needs to be 0, it will make sense once we've got the answer to what m is. So we need that to be equal to 0. Scroll down a little bit. Now remembering we can just keep that m is 6x plus 2 on the screen. So we've got 36 minus 36m plus 9m squared minus 72m plus whatever 36 times 7 is. It's got to be equal to 0. So that's 9m squared minus 108m plus 36 plus 7 36s. All right, so it's 8 36s. Got to be equal to 0. 9's in, yep, 9's go in. M squared minus 12m plus 32. So 8 and 4 is 12. So we got m minus 4, m minus 8 is equal to 0. M is equal to 4 or 8. Right, so coming back to the reasoning as to why this has to be equal to 0, you see we've got these two values of m is 4 and m is 8, both give us m is 0 there. So we've got two ways of getting our x solutions. We've got two values of m, but that gives us just two values of x because our discriminant has gone to 0. See, if we had values of m that gave us anything else inside this square root, then we've got 4 then solutions, because we're going to have plus or minus for each one of those. So if we had any value of m that wasn't 4 or 8, then we're going to get two values inside the square root. Then we're going to get a plus or minus, which is going to double them up, and we'll have 4 solutions. And those 4 solutions is this situation here. Whereas when we've got m is 4 or 8, it takes away the discriminant, but we're still getting 2 solutions in this bit because we've got the 6 minus 3m at the start there. So that's why we want that discriminant to go away, so that we get 2 answers. So we've got those values of m, and we said, what else did we say about m? M is 6x plus 2 from the gradient thing. So we've got 6x plus 2 is equal to m. So in this case, we're going to have that x is going to be equal to 1/3, and here x will be equal to 1. And then that means, what are we actually trying to work out? We're trying to work out the coordinates of the points. So y is going to be equal to, I've got to go back up again. So when x is, so it's m3x minus 2, just a bit easier than m3x minus 2. It's easier than using the quadratic. That's what y is. So, well, let's do the easy numbers first. So we've got 8 times 3 minus 1, so that is 8. And then we've got 4 times 1 minus 2, so minus 4. So our coordinates are a third minus 4 and 1, 8. Yeah, that was a difficult question when it comes to doing those sort of coordinate geometry ones. That was very tricky, I would say. So yep, that's all looking good. Let's see if we can get another couple in here, because I remember didn't this have 26 questions, this paper, I think. So right, question 21. Mars's moons Phobos and Deimos are in equatorial near circular orbits around Mars. They both orbit in the direction of the planet's rotation. Phobos has an orbital period of a third of a Martian day, and then we've got an orbital period of 5/4 Martian days. You observe both moons during the course of a Martian night. So I'm assuming that's like half a day. So a night is half a day, isn't it? So would the two moons appear to move in the same direction in the night sky? So what did they have here? So we've got a third of a Martian day and 5/4 Martian days. No, so one of them is moving quicker than the rotational period, because you've got one rotational period to go all the way round, but the Phobos is doing that faster. It's doing it 3 times, so whereas Deimos is doing it slower. So Phobos will go one way. You know, if Mars is rotating that way, we'll see Phobos will be going off quicker and Deimos will be going backwards. It's just relative angular velocity. So no, they'll be moving in. So how are we going to explain this for question A? So we can say relative angular velocity. We can say that Phobos will seem to go forwards, and as in that is so forwards because we're saying, well, it's going 3 times quicker is what we're saying on that, and the Deimos is going to appear to go backwards because, so that is because it's moving faster than rotation speed, whereas the other one is moving slower than the rotation speed. Right, describe qualitatively how the phases of the two moons might vary during the night. Right, okay. Right, so what's happening here? So during the night, we will see, so in half a day, so let's think this through. In half a day, we get Phobos will have completed over an orbit, completed more than one orbit, whereas Deimos will complete less than one orbit. So that means we're going to see all phases, therefore all phases of Phobos will be visible. All phases of Phobos visible. So because the phases of these moons, it just depends on the relative position. If you've gone through every single relative position in the orbit because it's done a whole orbit, then you're going to see all of the phases, but not all phases of the other. All phases of Deimos. There we go. Right, so C, would it be possible for the astronomer to see Phobos both rise and set in a single night? Well, yeah, of course it would. I mean, we're saying it's gone through all positions. So, yes, it doesn't ask for an explanation, so we'll just leave it at that. Right, that's good. I'll do one more, leave this video after we've done question 22, 5 marker. Right, a number can be represented using base n as follows. Right, that's just a description of what bases are. In which base less than 10 is the following equation true? Right, so this means that n cubed plus n squared plus, oh, there's no n, so plus 1 minus 3n squared plus, oh no, well, these are all minuses, so minus n minus 3 is equal to 3n squared plus 4n plus 4. So, well, we know that n is, well, it's got to be at least 4, and it's less than or equal to 9, right, is what they're saying. So what have we got on all of this then? So we've got an n cubed, that's the only one there. How many n squareds have we got? We've got minus 5n squared. So how many n's have we got? We got minus 5n's. And how many numbers have we got? We got minus 6. That's got to be equal to 0. So what are we going to get as a answer for n in all of these? Oh, it's a really annoying set of, essentially we're trying to factorize this cubic and see what the first number is, so we're just putting in all of the numbers. It might actually help. I'm just going to do a little n minus 5 on that, n squared minus 5n minus 6. I think it's going to be easier to spot what's going on there. So if we had this 6 here, is making me think that we're going to need something that's going to square and leave a 6 at the end. So 4s and 6s. So if we add minus 16, no, everything would be minus then. So yeah, we certainly can't have it. It's got to be greater than 5 then. So 6. So if we add 6 squared, yeah, 6 works, doesn't it? 36 minus 30 minus 6 is 0. So n is 6. Yeah, so a little bit finger in the air there. But yeah, actually, you can see that straight away. As soon as you factorize that bit out, because n has to be positive, so it's got to be at least 6 then, because otherwise we've got all these negative numbers. Anyway, that came out okay. So that's that video done. Question 22. Hopefully I'll be able to fit the last 4 questions in the final one.